Geometry, Unit 4, Lesson 5. I can prove the Pythagorean Theorem and find a missing side. So let's imagine that this right triangle we're looking at had some squares just grow out of each side. And imagine each of the squares was made of gold. If you were offered this big square here, or these two smaller squares together, which one would you pick and why? Well, I know what I would do. I'd first take a look and see how much gold I have in each one. This is 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 because it's a square. And 5 times 5 is 25. This is 4 by 4. And if you multiply that, you get 16 square units of gold. This is 3 by 3, making 9 square units of gold. Well, wait a minute. If I take the larger one, I get 25 square units of gold. But if I take both of the smaller ones, 9 plus 16 is 25. So they're the same. So it actually doesn't matter. Look at that again. This smaller one plus this other smaller one is equal to the larger one. Notice how we got this. If you take this side length right here of 3 in the right triangle and you square it, here it is. 3 times 3, that's 3 squared. If you take this side, 4, and you square it, 4 times 4, you get 16. And if you take the opposite side from the 90, called the hypotenuse, this side is 5, and if you square it, you get 25. It turns out that this side squared plus this side squared equals the hypotenuse squared. So if I came down here and I wrote a model about this, this is what I would say. I would say the sum of the squared legs equals the hypotenuse squared. What does that actually look like? Well, if I come over here, that would be a squared plus b squared is equal to c squared, where c is the hypotenuse. So c is going to be right here. And if you want to know where the hypotenuse is, I always start at the 90-degree symbol, and I kind of draw an arrow across. And that's how I always know where my hypotenuse will be. That's going to be the longest side in the triangle. And it doesn't matter where you put a and b, because since you're adding, it's commutative, a plus b, b plus a, it's the same. So a squared plus b squared will always equal c squared in a right triangle only. If I were to use segment notation, same idea. Okay, that's my c over here. So if I were to do a squared plus b squared equals c squared, I'm going to replace a, if I call this a and this b. A is really rg, so I might call it the distance from r to g squared. B is kg, distance from k to g squared, is equal to rk squared. Okay, so let's take this idea that the sum of the squared legs always equals the hypotenuse squared, and let's apply it. Here's the first example. Start with your formula, your relationship. Okay, a squared plus b squared is equal to c squared. Another way to think about that would be you have a leg squared plus another leg squared equals the hypotenuse squared. So I'm going to go ahead and figure this out. My longest side, I always start by looking at the 90 and come across. There it is. That's going to go right here. So I'm going to put a 10 right there. That's 10 squared. And then this leg here, I'll put right here. That's going to be 8 squared. And then I don't know the length of that side right there, but it's going to go in right here for my other leg. And I'm going to call it RT squared. And that's what I'm solving for. So I'm going to go ahead and simplify. That's 64 plus RT squared is equal to 100. I'm going to take 64 from both sides. And I'm going to get RT squared is equal to 36. Now you're not done. The way you undo squaring is to square root. Those undo each other, leaving RT equal to 9. So this would have to be 9 right there. Okay. All right. So if I were to try this one more time, okay, I could come over here on the other side. And I'm still solving for the missing side. The missing side is over here. And I'm going to go ahead and write a squared plus b squared equals c squared again. I'm going to start by finding my 90. So this is my c, so to speak. So I'm going to go ahead and put that in right here. I don't know what it is. So what that means is I'm going to call it AR. And then each of these legs is 10. So this is 100 plus 100 equals AR squared. 200 is equal to AR squared. And now if I square root both sides to undo the squaring, I get square root of 200. But that's not my final answer. I can reduce this. We need to use our lessons from reducing radicals. You can rewrite this as square root of 100 times square root of 2. If you have trouble with that, you can take the 200 off to the side and try and figure out what times what, maybe 10 times 20, 2 times 5, maybe 5 times 4, and you can start seeing the perfect squares that appear. And you can see you have 5 twice, so that's going to be 25. You know how to square root that. You have 2 twice, that's 4. You know how to square root that as well. And that'll help you figure it out. This, though, will make 10 square root of 2 for the distance from A to R. What is the most common mistake in this situation? Well, if you take a look, it really matters that you highlight and figure out what's going where. A lot of people will simply take the first 2 numbers they see and put them in for the legs, even if one of those numbers is the hypotenuse, which has to go in for the C. So I suggest always starting looking for the C. In this case, the most common mistake would be substituting the given side lengths incorrectly. Always find C first. Okay, so there you have it. Use the formula, highlight carefully, and substitute properly, and you'll be okay. Good luck.